monitor. Now, so we're doing synchronization before lunch. Okay. Oh yeah, turn off the light there, Andrew. Now, I was trying to show you the cost of synchronization. Okay. But the problem is that our machine is too efficient. So you can't actually see the benefits of synchronization. You probably won't see the benefits of synchronization on your own machine either, or the cost of synchronization. And the more, Jesus, heard that. Right, now, I've uploaded this code, so you no need to take it down. So I'll just explain what I'm doing, okay? Now, sorry? It's frozen. There's no need, I'll export it now this minute. Okay. Yeah. 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 Using as the monitor object to synchronize your block of code. Yeah.
Inside method or outside the method, which one?
Well,
it's no longer synchronized.
No. So it doesn't matter where it's changed. So I'll go up here again. I'll just go up here. So here, right? Now, if I change dog inside here, as I've done here, spot.dog count plus plus, this block of code is no longer synchronized. It's at that point, it stops being synchronized. So as soon as you change it, it's no longer synchronized. That's the way it works. Well, that doesn't matter. So that's fine. There's no problem with doing that. So new dog. Yeah, basically, yes, yeah. Okay. Inside there, or if something causes the dog to be changed. Okay.
So anything causes the dog to be changed outside the synchronized,
it's fine.
Still synchronized inside.
Yeah, well, it's right for now. Okay. My thing is after going a bit fucking funny here. Right. So at this point in time, so I'll take out that light. All right. Now, so spot has been defined as a new dog. Okay, so I even put it in here. Okay. All right. So now at this point, the code, all of this is synchronized. Yeah. Right. Now, if at any point during this code that this object is changed in any way, it's not a copy. Because that, here's the thing, it's not, no, well, what it actually is you have to, so to synchronize a block, that's not a method.
Right,
you, no, so, right. No, right. What it is. Whoa. Ease back now. Just chill out, you know. Light up there. Okay? Right. So here's a block of code. Right? It's not a method. So you have to synchronize that. So you synchronize it. Oh, geez, my spelling. That's not right, I know. Okay, so synchronizing. Now, you have to, an object has to monitor it that it's synchronized. And that can be any object. Okay? And so in this case, it's going to be spot. Okay? Spot is not, now spot can be used, it's not usually used inside there at that point, right? You don't usually use this inside here. The reason you don't use it inside here, because as soon as you change that object, that block of code is no longer synchronized. If you change it in any way, you change any of the variables inside here of spot, this block of code is not synchronized. if you assign a new dog to it, that means that this block of code is not synchronized. It's not really being passed in. It's just monitoring this block of code. That's all it's doing. Okay? And it's called a monitor object. Now that can be any object you want it to be. It can be a dog, cat object. Now the best type of object to use is a static, private, final object. Okay? Because if it's final, means you can't change it. You can't assign a new value to it. If it's private, you can't access it outside its own class, which you don't want to do because you don't want to change it. It's static. That means you can use this object inside both statics and non-static methods. Okay, so it should be private. And also, finally, now it can be any type of object you want it to be. But the best type of object is object, okay? Because it's only got a few methods, all right? And you're not going using that method for anything, you're not going using that object for anything else. You're only using it to synchronize blocks of code, okay? So you're not, the object you synchronize your block of code with, you shouldn't be using it inside here. Okay, I'll say that again. The object you're synchronizing your block of code with, it should not be inside your synchronized block. Because if it is inside the synchronized block, that means there's a possibility you could change it. However, if you make your object final, private, static, and make it an object, that means it's only got limited methods. Okay, means you can't change it, you can't assign a new thing to it, you can't assign it, you can't get at it outside of its own class. You make it static. If you make it static, that means it can be accessed in both non-static and statics, and you make it an object. By the way, what sort of object is that? There's another name for that type of object. It's a singleton. Remember them, boys? So the best type of monitored object is a singleton. Okay, it has one, well, actually, it's not a full singleton, sorry. A singleton can change its variables. Okay, whereas this guy, we don't have to change its variables. So it's not that it's been passed in JSON. All that that's doing, it's using that object to mark this block of code that only one thread, it's like a bouncer.
Yeah, so
That's exactly what it is, actually. Yeah, it's a bouncer. Spot here is the bouncer. Okay.
Anything happens to spot, everything else is not.
Exactly. Yeah. So that particular dog allows only one thread in at a time. Okay. If anything happens to that dog, he no longer can handle the threads. Okay. So it's not that it's been passed in, it's a bouncer. That's what it is. Okay. It only allows one thread in at a time.
And dog can't be changed outside really.
Oh, it can. It can be here. That's the thing. Right. So as soon as you change it, so if you change it at that point, that's fine, because that's before it goes into the synchronized block. Now, when it's synchronized, so let me just,
How would you change it outside though? Like,
how would you change it outside? Now, right, I'm trying to think now. Now, that's okay as well. Okay, however, we have to make sure. Oh yeah, we're fine actually. Yeah, that's fine as well. Okay, because
No, that area is synchronized up into the point where the main thread is.
yeah. Now, there is a possibility that this will cause this not to be synchronized. Okay. All right, because this is a system thread. Okay, this is the system thread. And oh yeah, that's fine. This is the system thread as well. Oh yeah, so yeah, they're fine. Yeah, you can access, you can change dog anywhere. As long as it's outside the block, you can change it. Okay, because that's the system thread. Okay, because it's a system thread, so that means there's nothing else happening in the system thread bar. That guy. Okay, so what synchronizing spot is a bouncer. That's what it is. Okay, only lets in one thread at a time. Okay, now one thread at a time, and then when that thread leaves, it lets in another thread. Okay, so only one thread can be doing something in that code at a time. Now, of course, this guy here, this changes spot, which means that this block of code is not synchronized. Okay, do you understand that? If you change the object in any way, in this case, you changed with variable inside the dog class called dog count and incremented by 1, that means that the bouncer is changed.
No, you said the 954 there, dot count minus
154.
4.
154.
Just for the error. Sorry, 194. Sorry, 194.
Here, yeah.
Yeah. You said just there, dot count minus.
There.
Yeah.
Doesn't make a difference because it's outside the synchronization block. Yeah. Okay. So, general rule of thumb is if you're going to synchronize a block of code, don't have the object you're synchronizing inside the block. Okay. And ideally, it should be private final static and an object. Okay. You're going to have an object specifically for synchronizing your code. Okay. And by the way, you can use the same object multiple times. You don't, so I could use, what was the name of my object? The name of my object, which was static final, was called, what did I call it? There it is, obj lock. You can use that in multiple locations. Is that okay? Right. Now, so then we synchronize methods. Okay, so I have a synchronized method here called sync count, and I have another synchronized method called stat sync count. Okay, and now, so then I have here cost of synchronization. So I've got the time before synchronization starts, and we've got a time after the synchronization happens. Okay. Now, in between, I create an examples object. Then I create a service with a fixed pool of size 10. Okay. Let's try that. Now, so I have a fixed pool of 2. So I'm only going to have 2 threads. Okay. Now, I have for int I is equal to 0, I is less than 900,000. So this is going to go 900,000 times. Okay. Now, these are all, so that's synchronized method. That's a synchronized method. All it's doing is incrementing count by 1. That's a synchronized method. That one there is also synchronized. Now that one looks like that. There's just a couple of synchronized blocks inside it. Okay. Now, so all that's happening there is that these three synchronized methods. So that's a synchronized method. This is a synchronized method. And this is a method with the with synchronized blocks inside it. Okay, so all of those, and all that does is just increments by one. That increments count by one. This is doing nothing. It just has three synchronized blocks inside it. Is everyone okay? Now that's going to take around a second. All right, it's going to take around a second. Then I go service.shutdown. Now I want to make sure that it doesn't print out before it gets to the finish. Okay, so I'm going to put the thread, I'm going to put the system thread to sleep for, that's 10,000 milliseconds, which is 10 seconds. Okay, this is just to ensure that this printout here doesn't run before this guy is done. Does everyone understand that? Okay, so this guy here is putting the system thread, thread to sleep for 10 seconds. Okay, so each one of these, so it's 3 nines, we're going to have 2.7 million method calls there. Okay, so there's 2.7 synchronized methods being called. So we're going to see how long it took. So this is EX5. So I'm going to run it now. It takes a while. So there she goes. Now she stops at that one. Let's just see. And she kind of keeps going again. Okay, she's taking her time. Okay, she's only at 1 million now. Oh dear, come on, come on, come on, come on. Now she's already completed, by the way. What's happening here, that's just taking this long to actually display them. Okay, so it should be 1,000 to 1,000. No, it's not appearing. Okay, I need to change that. So I need to change that to a pool of 10. Now I'll try that. Okay. That seems to be going a bit faster. Okay. So she's going, come on. I'm across my oh, maybe that's running a bit too long. Come on. No, 1,000 to 1,000. No. Okay. Let me just see. I'll change that down to 700,000. 5. It's worked 5 minutes ago. I don't know why it's working like this now. So let me just see. That's EX5. I'll try that again. Okay. Now it should, no. I don't know what's going on there. It was working fine before I fucking... Anyway, the upshot of it is, I don't know why it's not printing out there. Just something very strange going on there now. I don't know what I have done wrong there. Let it go again. Okay. 1002, 1003, 1004, 1005, 1006, 1007, 1000.
That's up to about a million, is it?
Huh?
That's up to a million.
Yeah, that's about right. So we're still going here. So that is 1, 2, 3, 4, 5, 10,000 milliseconds. Oh, that's a lot. That's 1,000. 10,000 milliseconds is, that's 100,000 milliseconds. That's 100 seconds. That's nearly 2 minutes. It's too much. So I will change that down to, let's say, 50 seconds, 20 seconds. 20, 1, 2, 3. That should be enough. So I'll try that now. All right. So let's see. So it's going to sleep for 20 seconds. So this should get done in 20 seconds. Okay. So 1,000, 2, 1,000, 3, 1,000. No, I don't know what's wrong there. No, it's something fucked up. I'll figure out. Anyway, the upshot of it all was, okay, is that this guy here, it's got 3 synchronized methods. Okay. I had one down here with 3 non-synchronized methods. This was on average around 2 or 3 seconds longer than this one. Okay. So I can't get it displayed for some reason or other. I don't know why. But this one was on average 2 or 3 seconds. Okay, right, that's fine. So 14, 21, 32, 43. So this is 31,028. So that is 28 from 243. That is 2,1. What is this? 215 in the difference. Yes? Yeah? So 205 milliseconds. Huh? Oh, it is 2. Okay? So 0.785 in the difference. Okay? Now, if I run the exact same down here, so this is a pool of 10, and this goes to 500,000. So the other one was 785, yeah? Okay. So we try and see the difference here. Oh, at least those guys seem to be going faster. Okay. 785. So she's running, and we'll see. Yeah, that one's not doing now either. Anyway, fuck it. See, sleep. I put it to sleep for 30,000 of them. So we'll have a look at this one and see. That's 30 seconds. That should give us enough time. So we will see it's still going red. So she'll print out, Go on, go on. So, okay, that isn't an awful lot of difference. All right. Now I'd have to mess around with it before. That's why it took me so long to start this morning. I was getting 2 seconds of a difference between the two of them. It's not, I'm not seeing it there. So I've done something wrong. But there is an awful difference. All right. There is an awful difference between synchronized and non-synchronized methods. You can't see it there, but there is. Is that okay, everyone? Yes? Okay. Can't see it there, unfortunately. Now, the last thing I want to show you, all right? So this is static void ex7. Now I created a new class called myThreads. It's a very simple class. Inside it, it has private int I is equal to 0, public void increment, and all that happens inside the increment is that goes I++. And then we have a get value. All right? Nothing too difficult there at all. Now, I created this. So executor service, executor's new fixed pool, I've only got 2 threads. I've got a task. All right, now I created a threads object called my threads, I called thread. So inside the task, I call the increment method, which is that guy. And also inside the task, I also say value is thread.getValue, which is this guy. Okay. Now, then I have an ordinary for loop. For int I is equal to 0, I is less than 4, I++. So that means this task here is going to run 4 times. Yes? So if it was running as normal, single-threaded application, it would print off thread.increment, would print off 1. Then it would print off value is 1. Then it would go 2. Then it would say value is 2. Then it would go 3. Then it would say value is 3. Then it would go 4. Then it would print value is 4. Yes? That's what should print out if it was just a normal single-threaded application. But this is a multi-threaded application. So look what happens when I do this. Oh shit, that's the wrong one. Fuck off. So examples are ex7. Right. So we get 2, 2, no mention of 1. Then we get value as 2 is appearing twice. Then we have 3, value is 3, 4, value is 4. So 1 never happens according to this. All right. And also 2 is appearing twice. Also, this statement is appearing twice. So it's, if you run it again, it's the same thing again. I get different. Well, let's keep getting to 2, 2. Okay, so it's obviously getting it from cache. It's not actually working it out there at all. It's just saying, I won't bother working it out. That's what I'm getting from cache. All right, but it's not producing 1, value is 1, 2, value is 2, 3, value is 3, 4, value is 4. Okay, if we change this slightly, so I comment out that guy. And I'm going to use this guy instead. Okay. So I don't need to thread.sleep inside it. Okay. So we go second synchronize block, goes threads is equal to new my threads. Then I synchronized obj lock. So I synchronized the for loop. Okay. I synchronized the for loop. Let's see what that looks like. Fuck yeah. Hold on. Thread.sleep. Well, bollocks. Okay, why am I getting a second 2 there? Hold on a second. See. No, what have I done wrong there? Well, so much for fucking getting this. All right. Give me a minute here. So what have I done wrong here? So, let's see. Thread sleep. Okay. So let me just see. Oh yeah. So I need to go. Thread is equal to new my threads. Yeah, I don't know why it's doing that now. 1, 2, 3, 4. Value is 2, value is 2, value is 3, value is 4. 1, 2, 3, 4. Okay, we're seeing one of the problems of synchronization is that they're a bitch to figure out what's happening. Okay, I do not know why it's going value is 2, value is 2 there. It should be printing off 1, value is 2, value is 2, 2, value is 2, 3, value is 3, 4, value is 4. It's not doing that. If I increase the amount of pool. Nope. Anyway, I don't know. Okay. Well, what it should be printing out is the following: is 1 value is 1, 2 value is 2, 3 value is 3, 4 value is 4, and it's obviously not doing that. Okay. Sorry.
You can't separate it into print out first thread, then the next one, the next thread increment.
No, but you see, I'm putting to sleep the system thread here. So, no, that's not going to do it. Let's go 1, 2, 3, 4, and then we get 3, 3, 4, 4. Shit, fucking done something wrong. I don't know what I've done wrong. No, Jesus, we're not going anywhere near those things. Not yet. Okay. Just say try that. 2, 2. Fucking hell. Put that guy to sleep. I'm getting the 1, 2, 3, 4 correct, but the value thing is not correct. Sorry? No. It doesn't make a difference. Yeah, thread dot increment. That's just incrementing it. Fixed thread pool. Value is thread dot get value, thread dot sleep. Second count is equal to 0. Thread submit task. Task 1. Yeah, I don't know why now. Synchronize OBJ lock. So that should be synchronized. Service.submit. Okay. So only one thread can enter that at a time. But inside here, more than one thread can access it. Yeah, guess what? I'll have to come back to it. Okay, I'll have to come back to that because there's something fundamentally wrong with my logic there. I thought I had it working before I came along. Anyway, synchronization finished with a bit of a bust, but we will come back to it. We'll have to come back to it to figure out what's happening there. Is that okay? All right. Now, so the two ways you can synchronize access to your data is either having an atomic class or synchronizing blocks of code. Okay, synchronizing blocks of code can be iffy enough, as we can see here, and trying to figure out what's happening a lot of the time is fairly difficult as well. All right. Now, if you are synchronizing collections, now what's a collection? A collection is a list set queue. Now, a map does not, hash map does not implement the collection interface. It implements the map interface. Okay. Now, but none of those sets, lists, queues, or maps, none of those are thread safe. All right. So none of the collection classes or maps are thread safe. That means you can have multiple threads accessing the one element in a list, a queue, a set, or a map. Do we understand that? Now you can imagine the havoc that can cause. If you have 3 threads accessing the one element at the same time, and all 3 of them are trying to change the one element at the one time. Okay? Now, you can set up these things called forks, or you can set priority threads. All right? There's a simpler way. There is versions of lists, there's versions of sets, there's a version of a queue, and there's a version of the hash map that are all thread safe. All right? That's what the next section is about. Okay? So the next section is going to be new. You have a project. So this is 7.4. And this is using concurrent collections. Okay, and I need to stop that video.